Hello everyone, today we'll be going over our data structures and algorithms course. Today focusing on doubly linked lists. And without any further hesitation, let's get started. So doubly linked lists are a type of linked list in general that allow the connectivity of elements for both forward and backward, unlike a singly linked list where one needs to actually iterate directly from the head. And this is really efficient in terms of the time complexity whenever we are storing or deleting or searching a specific element, for everything is already connected based on each elemental node inside of the doubly linked list. So to be able to construct everything and to be able to go further in depth, I'm going to first start off with the libraries. So as we know, we do include iOS stream. And then we're going to use using namespace std to save on time. Then I'm going to have a class. Let's call this doubly node. Over here, and it's going to be a public class with data that will be in integers, and we're going to have a doubly node referred to next, and then a doubly node referred to the previous. There we go. Then doubly node we'll have integer of values, and then data with the value, and we're going to initialize our nodes by using null pointer and then previous pointer. Let's move that out of the way. There we go. So we have that. Just fix that syntax over there. There we go, null pointer. And then we'll have class doubly linked list. We'll keep this whole thing public to start with. We'll have a doubly node referred to as the head, and doubly node referred to as the tail. Then we're going to call upon a function doubly linked list. We'll have head, null pointer. This is how we initialize, and then we'll also have the tail for the null pointer. And so we're going to have our functions. In this case, to be able to just showcase the simplicity of this, we're going to do insert, and then we're just going to print the list. And eventually I'm going to have a key function for a doubly linked list, but we're going to save that for later. In the meantime, we're going to focus on the functions for insert. So void insert int val, where we have doubly node, new node, equal new doubly node for the value. And we're going to have this condition statement if the tail does not equal to the null pointer, for we need to determine, as we're inserting elements inside of our linked list, we'll have tail next equal the new node, and we're going to have the new node the previous node that we have equal the tail. Notice how we are using the swap technique like we did beforehand in the singly linked list. And then we're going to have to redeclare tail equal to be the new node. And then if there is no element inside of tail, then we're going to declare head to be the tail and indicate it as the new node. We assume on that case. There we go, so that's insert. And then we're going to be printing the list, so void print list. There we go, and the way how we'll be doing that, so we'll have the doubly node temp equal head. We'll do a swap technique as usual. And while temp doesn't equal null pointer, cow temp data next. Small syntax. And now we're going to have our main function that we have over here. We'll have doubly linked list. Call it list. And then we're going to call upon the function list insert integer value. And we're going to do this for 3 elements as well. So we're going to have 1, 2, 3. And then we're going to output our doubly linked list. List.printlist over here. And as our base case, we will return 0. So let's build. Let's succeed it. Let's run this. And it prints our doubly linked list accordingly, much like in the case of singly linked list. Now, a key function and a key functionality with what makes doubly linked list very, very efficient is the accessibility to be able to delete, insert, and or search for different elements as well. For we're able to search, instead of directly going at the head like we would in a singly linked list, we're able to search specific elements throughout our doubly linked list, since everything is comprised inside of a chain. So what I'm going to be doing is that I'm going to have a temporary, I'm going to have another function called void delete node. It's going to have the values. And then we're going to have doubly node, a temporary one, set it as the head. And while the temp doesn't equal null pointer and temp doesn't equal data, doesn't equal the value. I'm checking so far. We are going to set the temp node to be equal to the temp next. We're going to be going for the next one. And then we're going to have a series of Boolean conditions as well. In this case, where we'll be checking to see if the specific node is not found. We're just going to be returning saying it's not found. Then we'll have another case, and mind you, I'm just doing edge cases right over here. If the previous temporary node has a value, we set the next one accordingly. Then if the temp node, next node, has a value, we'll see about the tail. Otherwise, go for the head. And finally, we delete the temporary node. So these are the three different if statements that we're going to be checking between the head and the tail. So doubly linked lists are widely popular for sliding window techniques as well, especially when one goes further in depth in LeetCode and Line 75 and C++. Namely, they will be able to utilize some techniques of doubly linked lists as well. So now I'm just going to take care of these edge cases that we have over here. So if the temp equals null pointer then we're going to output node not found. Here. I'm going to have another if statement here. If the temp with the previous doesn't equal the null pointer, I'm going to set temp to prev, and the next one equal to temp next. Otherwise, we're going to set the head to be the next one until we start finding the specific value that we are looking for. There we go. And then we're going to be focusing on the tail side. If the temp next doesn't equal the null pointer, temp next. And previously, much like in the case of what we did for the head over here, we're going to be focusing on the tail. Now we'll have temp be the previous, else we'll have the tail equal the temp previous over here. Now checking to see if there is a number or no number whatsoever. Finally, we will delete the temporary node. So we'll have delete temp count node with value val deleted. There we go. Now for the next part, I'm going to delete our node. So list.delete node, let's go with number 2. And then we're going to output our new doubly linked list with deletion. List.print list. There we go. Yes, indeed. Okay. And we can see right here that this is our new doubly linked list along with our doubly linked list. Compare the two accordingly. Notice how we applied the swap techniques that we have already situated right here for the tail as well as the head. And we have a temporary node that we use as a placeholder, really. We put it as head to assume that it is at the beginning, and then we're going to be scanning while we are going through our array. In the delete function, we're having these Boolean conditions really to be able to check where the specific value is and to determine if it has a number or not a number, but then we have to check to see in particular at that specific value to be able to delete the temp. For this is just a common function that is used widely within the C++ libraries, so that's why we're able to call upon delete, and it will completely delete the following value that we have here. And I will put this in the comment section as well, so we have a full look and understanding between it. So let me see if I can zoom this out for a second. You folks can get a good look. So here's our main, here's the Doubly linked list, and then that's the beginning as well. And so yes, this was Doubly linked list as well for a linked list data structure series. Hello everyone, thank you again for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions as well, feel free to put it in the comments section. And as always, take care. Cheers. Bye-bye.